Okay, so as I mentioned, some of this stuff is obviously going to be stuff that you more experienced users know about, but these are going to be things that I consider to be essential for all Flying Logic users to know about. Um, Also, as you know, Flying Logic runs on Mac and Windows and Linux, as a matter of fact. The Mac has a menu bar on the top of the screen. For this format, my menu bar is way off to the left-hand side. You couldn't see it even if I showed you that high on my screen. So I have a plugin which lets me pull up the menu bar as a pop-up menu. So basically, there's the Apple menu, there's the app menu, Flying Logic menu, and so on. So if you see me pull this dark menu up, that's the actual menu bar. If you just see me pull up the regular kind of context menu, then that's what that looks like in Flying Logic. All right, so let's start with an overview of just kind of the major parts of the interface. Obviously, the big blank area is your canvas, and it's where you're going to construct your Flying Logic documents. Actually, I think Tom, right? You referred to it as a model, and that's actually a better term for what Flying Logic creates is models rather than diagrams, even though the output is a diagram. I think of Flying Logic as modeling software, not so much diagramming software, because it gets compared a lot with things like Lucidchart and Visio and things like that. And part of my crusade is to say, no, it's not like those things at all. And the similarities are superficial because it approaches things from a very different point of view. And so I'm going to be coming back to that point a number of times. Along the top, you see the toolbar, and we'll be touching on a number of those buttons, but not all of them. And then the left-hand side is the most important area, which is the sidebar. And it's broken up into a number of sections called inspectors. These inspectors are resizable. They have a title at the top: domain, layout, operators, text. And these are the 4 inspectors which are most useful in day-to-day work. There's other things like the document inspector. You can show it using these buttons on the side that gives you like metadata about the document, or the navigation inspector, which shows you like a thumbnail of your document, lets you navigate around it very quickly. And the navigation inspector is one of several ways that we have to manage larger documents, because as your documents grow, you're going to want to focus either on the big picture, and the navigation inspector helps you do that, or on smaller sections of your documents. And we'll be covering a couple of ways of doing that. So these 4 inspectors, domain, layout, operators, and text, we will definitely be touching on in this presentation. There's basically 4 elements of a Flying Logic document, and they're entities, edges, junctors, and groups. And we're going to be discussing each one of those in turn. So entities basically are always classified by what I call an entity class. And this is something that didn't exist in the whole TOC world before I kind of came up with it for Flying Logic, because I realized that when you draw a rectangle and some letters in it, as a programmer, as an engineer, I realized, well, what are we talking about? What kind of concept are we talking about here? And so when you create an entity in Flying Logic, it comes with a class, like say action. So in this case, I'm dragging from the domain inspector into the canvas. Now I go, and it creates an action. And there's a couple of things I want you to notice about this. One, that it's highlighted, that it's selected by default when it's created, and that's very important. We'll come back to that. And the other is that the entity class is the one that I just selected. If I just deselected it and then selected, say, goal, and click the new entity button up here, a goal would be created. Now it's selected, and so that the thing that is created new is always selected by default. And also, this button paid attention to which entity class I had selected here. So if you want to create a goal and you just want to do it by the new entity button, or for example, by saying new entity, which is Command E, then this is the class that will be created. That is whichever one is currently selected. Now I have 2 entities in the document at this point. They're unconnected. And so the next concept is that Flying Logic has kind of a gestural language you use to construct documents. One of the gestures, the only gesture you've seen so far, is me dragging from the domain inspector to the canvas. And the second gesture is to drag from entity to entity. When I start dragging on an entity, you notice that this gesture arrow appears. If it's pointed at an object where nothing's going to happen, it's red. As you've seen, the highlight is red. If it's pointed at something where something will happen, it's blue. And so you get some immediate feedback while you're dragging as to whether or not it's actually going to do anything useful when you let go. So if I wanted to connect my action to my goal in a causal relationship, then I would drag from the action to the goal. So when I let go, you see they're connected by a new edge. And notice that edge is now highlighted because it's the new element that's been added. And that's the second element of the 4 elements of Flying Logic, edges. Edges represent the relationship between the concepts contained in the entities. And how you read that arrow depends on the kind of technique you're using. If, like, for example, like me, I will use Flying Logic for things that have nothing to do with TOC, like software dependency diagrams where one package depends on another. And in that case, I might read the arrow as depends upon. So package A depends upon package B. Well, when you're using like the theory of constraints thinking processes, you often read the arrow as is sufficient to cause. That means if I take this action, that me doing that is sufficient to cause the outcome, which is the goal. There's another way of construing the arrow using other techniques, which is a necessary condition. So for example, if I have two possible actions, let me create another action here. I'm going to connect it also from C to B. If there's two possible actions, how I read these arrows would be dependent on whether I'm thinking about them as sufficient cause or necessary condition. If I'm thinking about the sufficient cause, then either of them is sufficient to cause B. If they're necessary conditions, then both of them would have to be, because they're necessary, but they're not sufficient by themselves. So how do I know which way I'm reading the arrow? Well, Flying Logic is, as I mentioned, it's not just a diagramming tool. It's actually a modeling tool. And in many cases, the built-in, the logic you're describing can be stepped through in Flying Logic. So one of the easiest ways of doing that is using this button here, the confidence spinners. You turn those on, and these little pie charts I call spinners, they all start out at kind of not yes, not no, not true, not false, but kind of maybe 50%. And in this case, the way Flying Logic documents are set up by default, the relationship between two arrows pointing at another entity is an or relationship. That is, either is sufficient to cause the goal. So this is basically, these are sufficient causes for B. So for example, I can drag up and down on the spinners and you can actually see them move. So if I go all the way to false, it doesn't go all the way to false because this one's still maybe. But if I go all the way to true, you'll see that the other one becomes true. Oops, drag too far. All right, so as you can see, because either of these are sufficient causes, doing either one causes the goal to become true. And now, as you can see, dragging is nice because it's animated and kind of shows you the logic in a very vivid way. But you can just use keyboard shortcuts as well. Flying Logic has a lot of built-in keyboard shortcuts. Like for example, I can select an entity and just press F, and that's F for false, or T for true, and or even 5 for 50%. So you can go like 1 for 10%. So it's important to realize that you can have one or more entities selected and adjust their confidence values, very quickly. For example, if I want to set these both to false, I've already selected A, I can hold down Shift and select C, so they're both selected, and then just press F. And so they both go to false. So if you find yourself doing something in a repetitive way and you think there might be a shortcut, there probably is. And if you can't find it, of course, the docs.flyinglogic.com has a complete list of keyboard shortcuts, but if it can seem overwhelming, feel free to ask in the chat if there's something you're trying to do and it seems like you're finding it tedious. I've probably had that experience myself and probably found a way, provided a way around it. So, in this case, as I mentioned, two arrows or edges entering an entity is an or relationship. Now, but I also said that that's not the only way you can read them. Sometimes you want them to be an and relationship or necessary conditions, where one is necessary but not by itself sufficient. So how do you model that? Well, this inspector, the operators inspector, has two very important pop-up menus. And the top one is called the entity operator. Okay. And it's set to or right now. Now, Flying Logic has a bunch of different operators built into it, but really most of the time you're going to stick with and an or. And it's set to or right now. So if I pop it up, you see the top two are and or. There's also exclusive or and a bunch of other ones you can use if you're using more numerical methods. And I've got examples in the Flying Logic examples folder, which I'll show you in a minute. About how to use those, but most of the time just stick with and or. So if I want these to be, if I want this document to reflect necessary conditions instead of sufficient causes, I would change this to or. And now if I change this one, then this is sufficient. This is I'm sorry. Yeah, this is a, that is already set to or, sorry, my bad. So it's set to and, notice that immediately becomes false because now these are necessary conditions, but they're not sufficient by themselves. So now if I put them both, press T for true. Then finally it becomes true. But if I add another action, which would be a necessary condition, then it immediately goes to maybe. Also notice that I did something different here. I didn't just drag to create an entity and then drag to connect them. I actually did a single drag. Let me show that to you again. So I'll undo that. And I'm going to drag from here. And notice that as I drag around the diagram, there's all these little drop zones, as I call them, that appear. There's ones before and after. There's one right on the arrow. There's one right off the edge. There's one before and after. These all have different meanings. And where you drop something, most of the time you don't create free-floating, unconnected entities. You actually create them already connected where you want them to be. So if I want this to be another predecessor of the goal, another necessary condition of the goal, there's a drop zone for that. And that's right to the left of the goal. So I put that there. And now you see that actually it's created two elements, both the entity and the edge that connects it. And it's highlighted them both. So I can see that no matter how the layout changes as I work with the Flying Logic document, that the new objects are selected by default. And as I can say, if I don't do this action because I've set it up, this is an AND relationship with the entity operator, then the goal becomes false because I've said these are all necessary conditions. If I set it up back to the default way where it's or, then it becomes true because two of these things are true and only one is necessary because they're all sufficient causes. So when you read about sufficient cause or necessary condition, that's really the entity operator. All right, so the third element of Flying Logic, I will show you now. So another gesture you can do is to drag. Remember, the two gestures I've shown you are dragging to the canvas and connecting, and also dragging to the drop zone, the predecessor drop zone. So what I'm going to do now is I'm going to drag a precondition directly onto the arrow. And you see there's this kind of darker circle in the middle of the arrow. You can target that, and you can see it's on all the arrows. If I drop it here, then actually it creates four new elements. It creates the entity I wanted it to, an arrow, a junctor, and another arrow. So these are all highlighted now. And this is the third element of Flying Logic, the junctor. Junctor is a contraction of the words junction and operator. It's a junction because it combines things. If you've seen theory of constraints diagrams, they will actually have two arrows entering an entity, and they'll draw a big kind of banana shape over those arrows to show that's an and relationship, not an or relationship. When I designed Flying Logic, I needed something kind of more flexible and kind of something that works with the way computers lay out things. So I created the concept of the junctor because it is more flexible. You could actually have it have any of those operators I mentioned, and you can mix and match them as you desire. A precondition, the way I've described it in thinking with Flying Logic, is the thing that has to be true before an action can be taken, or the action will be useless. So that's why I use and relationships. The precondition has to be true, and that basically kind of unlocks the action. So for example, if this precondition is false, let's say I haven't done either of these. If I want to take this action, well, I can set it to true, but the goal won't become true because the precondition is still false. So before I take the action, I have to make sure the precondition is true. So if the precondition is true, I take the action and the goal becomes true. So the junctor basically overrides the or relationship with its own kind of relationship. The two things entering it are combined using the operator inside the junctor. So I'm going to add preconditions for my other actions as well. Personally, I think whenever I do these kinds of transition trees, as they're called, where I start with a goal and work my way backwards to actions, I think all actions have to be combined with preconditions. That's just my methodology. Flying Logic doesn't enforce that kind of formalism on you, but if you want it, it's there. So I'm going to drag another one here and drag another one here. And now I have my actions combined with preconditions. Now, I can also say that, for example, some of my actions, if I take them, might also result in other kinds of effects, like undesirable effects. And in the world of TOC, that's called a negative branch reservation. It's basically saying, hey, have you thought through not just what you want to happen, but what you don't want to happen? And I think that's one of the things that really turned me on to the theory of constraints in the first place is, wow, it requires you to really think through the kind of second and third order effects of what you do. And that's the whole focus of a future reality tree. Which again, use the same kind of effects-based planning entities to do that. That's specifically designed for you to help make sure that your ideas don't get out of hand by causing more problems than they're designed to solve. So let's say I have an action here, C, that I want to be a successor to C that is also an undesirable effect. So there it is. So now if I take C obviously in this case, since the precondition was true, I wouldn't get my goal. Let me set all these to false. So I'm going to option drag around all these and press F. It's that easy to set your scenario back to the beginning. So if I, for example, if the precondition is true and I take the action T for true, I get the goal, but I also get the undesirable effect. And so basically what you do is if somebody says, hey, there's this undesirable effect that would happen if I take this action, then you have to come up with a plan to mitigate it. You basically say, okay, well, if we could have a better outcome to this, if we're going to let this happen, what would a better outcome be? And what would be the action that we'd have to do to take that action? And what would the precondition for that action have to be before we could take it? All right. So notice that even though Flying Logic did a fairly radical layouts there, they kind of flipped the diagram. I didn't lose track of where it was because every time I was creating new things, I just look for what's highlighted. And as soon as I see what's highlighted, then I know what's changed. And I don't worry about the layout because that is Flying Logic's job. And now there is one thing you can do to mitigate that big flipping. In fact, let me update that. Let me undo that last thing there. I'm going to redo that, but I'm going to turn on this switch called Incremental Layout in the toolbar. When I drag that precondition to the same edge I did before, you notice that it was made a much smaller change. And that sounds great, but why wouldn't you leave that out all the time? And the answer is that Flying Logic has rules about how diagrams flow. You know, so these arrows are all pointed to the right. What that does is it causes Flying Logic to relax its rules considerably so that arrows can go in any direction. So if you keep this on all the time, you may start seeing arrows flowing backwards or straight up and down or whatever, but not flowing with the general flow of the general diagram. And you may find that it makes choices which, that was a small change, but the diagram kind of is harder and harder to read. So when you're ready for it to kind of do a fresh layout, then you just turn the switch off. It does the layout it thinks is best, and then you can go on from there. I often find the incremental layout is really useful because I don't use it a lot when I'm constructing documents, but when I'm showing documents to other people and I want to make a little change, and I don't want them to be freaked out by the fact the diagram just flipped, then I turn on incremental layout and make the change, because almost all the time it results in a very small change. Some people prefer to leave it on all the time. I suggest you experiment with it and figure out what works best for you. So now that I have this kind of sequence of events, I want to talk a little bit about how you title objects, because as you've seen, often, right now I have a very abstract diagram here, and I'm not going to make it any more concrete for time in this, but I do want to show you how you title various things. So when I create, say, a new element, like let's say I just created this K element here, you see that several things were selected. Okay, so all those things were selected. So when I press the tab key and several things are selected, but only one entity is selected, it unhighlights all the ones except the entity. And when only one entity is selected, I press tab, then it brings up the title editor. And then I can type my title, press return, and then I've entered the title. So whenever you create a new entity, let's just create, say, another action here on my goal, another possible way of achieving my goal. Okay, so now you see the two new elements are highlighted. I just press tab, and then I can type my title. So usually there's very fast ways of entering the necessary text. Down here in the text inspector, you see that the title of the selected object is here. There's also this large area called the annotation. And annotation text can be anything you want. It can be long form. It can even be styled text. You can see bold, italic, underline, strike through. You can even put links. When you create a link and you lock the field like this, then the link becomes active, and you can link to websites, other supporting material, things like that. So that's kind of much more free form there. But notice that when I click outside, this little yellow bullet appeared here, and that bullet basically shows there's an annotation in addition to the title. All four elements of Flying Logic documents can be annotated. We've only covered 3 of those elements right now, but as you can see, the actions can be annotated. Edges can be annotated, and often that's very important because you want to document your assumptions about why one thing causes another. So if I select this and I press tab, there's no title on an edge, but it moves me immediately down to the annotation field. And so I can type my annotation, click out of it, and you can now see the bullet there. Edges, are special in that if you you can basically annotate an edge. Let me do that here. And then if you right click on an edge, you see this command, show selected edge annotations. If you turn that on, then the edge itself, basically the actual annotation appears on the edge, and you can even edit it on the edge. So if I press tab, then immediately the edge annotation field appears, and I can edit my edge annotation text. Press return, there it is. So edges basically have this kind of superpower of being able to show their annotations directly. There are certain kinds of diagrams where you want to show them on every single edge. One particular diagram like that is the evaporating cloud. The evaporating cloud is used for conflict resolution. And because often when you propose solutions to problems, somebody says, yeah, that's never going to work because we want this. Well, okay, so you want that, but to make the solution work, we want this. Well, how are we going to solve this conflict? And so conflicts come up very often when you're trying to solve deep problems. Flying Logic has a set of built-in examples and templates. If you pull up go to the file menu and say, open examples, then this examples window opens that has both documents and domains. Domains are these groups of entity classes. We're going to go to documents and conflict resolution and open up this cloud.xlogicT. T means template. And then when you save a Flying Logic template, it always opens as a new untitled document. So if you've got a template set up the way you always like it to start out, with the domain set up and everything set up the way you want, then you can save a Flying Logic document as a template. And so this is kind of a generic template for an evaporating cloud. And there's a couple different things you should note about this. One, it flows right to left instead of left to right, and that is set up in the orientation inspector here under layout orientation. Traditionally, Flying Logic, traditionally evaporating clouds are set up to flow from right to left because the common objective between the two parties is the most important thing you want to emphasize, because these are both necessary conditions. The needs are both necessary conditions for the common objective. The other thing to note is that the entity is set to and, not or. So these are necessary conditions. Both of these have to be true to achieve the common objective. So when two people say they want different things, I want this and you want this, but we can't have them both. Flying Logic actually has a really vivid way of showing that. If I turn on the confidence spinners, you see that the conflict entity is set to true, which basically flows through this to be true. And therefore this is met, but this is not met because both of these aren't true. Meanwhile, there's this red arrow there, and that's something new. All edges in Flying Logic also have what's called an edge weight. And the edge weight can be set to positive, neutral, negative, or anything in between. If you can, in fact, there's a shortcut here. You can right click on it and just set the edge weight. If I set this to positive, then everything is hunky dory because we both get what we want. Therefore, we both get what we need. But that's not a conflict. If the conflicts, if what we want aren't mutually exclusive, then we don't have a conflict. So that's one way of resolving a conflict, is realize that you can both have what you want. But let's set this back to negative. So now we both can't have what we want. And in fact, if I've changed this from true to false, you see that now you get what you want, but I don't get what I want, and our needs aren't met, so our common objective isn't met. Remember, these are what we're asserting by this diagram is that these are both necessary conditions for our common objective. Our common objective might be an initiative at work or living together under the same roof or any kind of thing. So when people say what they want, they usually say what they want because it's in service of a need that serves the common objective. And so the whole purpose of an evaporating cloud is to surface all these assumptions people are making about their conflict. One of them is that we can't both have what we want. Well, maybe we both can't have what we want. So what do we do? Well, we understand the need that serves the common objective. But even more deeply than that, it's like, why does what I want serve my need? Why do I think that? And for that, we need edge annotations. Now, we could just come over here and type annotation, and then we get our little yellow bullet. We can hover over it. We could even say, show selected edge annotations and bring it up so we can see it clearly. But in an evaporating cloud, you often want to show all the edge annotations at once because you want to fill everyone out because you want as many different possible ways of attacking the problem as possible. So there's a toolbar menu called item called edge annotations. When you turn that on, it shows all the edge annotations regardless of whether or not they have any text in them. And then you can simply click on one, press tab, and type the assumption and kind of treat it like a form to fill out why you think this need serves the common objective. And so you try to strive for as much agreement when you surface these assumptions as possible. Yes, this need does serve this common objective. And, Flying Logic is as much a communication tool as anything. You can do a diagram or a model in Flying Logic just for yourself, but often you want to have clarity on something with somebody else. And so making sure you agree on the presumptions, the assumptions underlying these things is super important, especially when it comes to things like conflict resolution. So, once you've done that, once you've gone through all these things, then it's time to come up with creative brainstorming and come up with solutions, or what they call injections sometimes. So a solution is a way of breaking the cloud, because if anything, the thing about the evaporating cloud that's brilliant is if any one of these assumptions gets subverted or broken, the whole cloud evaporates. It actually means the conflict is gone. So let's say there's a way of me getting what I need without necessarily getting what I initially wanted. Well, how would we represent that? So we could say, take a solution and make this a predecessor. Oops, put that in the wrong place. Oh, hey, this is a good example, a good time to show you this. So I misdragged that to the common objective. I meant to put it on the need. So Final Logic has these hover points over the ends of arrows. And all you have to do, not there, that's not the end of the arrow, that is the end of the arrow, is to drag from, say, the head of the arrow to where you actually want it to be. And there it is. So now what I'm trying to say is that if I do this solution, then my need will be met, which will meet the common objective. Well, there's still a problem, because if I say, okay, well, let's implement the solution, well, why isn't the common objective met? And remember, the arrows here, when they're combined with the entity operator, which is and, this is a necessary condition. So I've just added another necessary condition. Well, that's not what I want. I want this to be a solution. I want this to meet my need. Well, how do I do that? Well, the way you do this is you use an or junctor to combine it with this. So it's not just me and my want, or I want the want or the solution to be met. And so I'm going to drag from this, and this is another gesture, new gesture, from the head of an arrow to another edge. And this creates a new junctor and a new edge. And the junctor that was created in this case was an or junctor. Well, why not an and junctor? It created an and junctor before. Well, that's because in the operators menu, the default junctor operator is set to or. So when you're doing a sufficient cause diagram, generally you set this to or and this to and. If it's the necessary condition diagram, like the evaporating cloud, you set it the other way around. So the entity operator, which is here, these combines these two edges, is and the default junctor operator, that is new junctors, are ors. Now what I have is my solution is implemented, which meets my need, and that's a necessary condition. You get what you want, which meets your need, and now the common objective is met. So I haven't had to erase any lines or anything like that. I've just injected the solution with an or operator, and the conflict is now gone. It doesn't matter, at this point how this is set, because the common objective is always met. So, and again, feel free to ask questions at any point, because I know I'm covering a lot of material in a short period of time here. So let's go back to our original document. And by the way, you can open up, you can set Final Logic to open up new documents in tabs or as separate windows. It's entirely up to you. So we've talked about 3 of the 4 elements of Final Logic, and we've talked about entities, edges, and junctors. Now we're going to introduce the 4th element of Final Logic, which is groups. So right now, all of these are kind of at the same level, and it's kind of laid out very two-dimensionally, but we're going to start adding a 3rd dimension to the diagram, which is how we group things. So for example, we have this action which causes this undesirable effect, and we have this mitigation plan. Let's say we wanted to kind of put that all in one package. So I'm going to hold down the option key and drag around these elements here. And then I'm going to use the toolbar button up here, which is also Command G, or in the group menu, new group. And I'm going to create a new group. And that creates this blue rectangle. Now, there's, as I mentioned before, when you create new elements in Final Logic, they're always highlighted. And when you press Tab, you go to the most obvious next thing to do with it, which is basically, in this case, you want to title the group. There's 2 kinds of elements in Final Logic that can have titles. Entities, you've already seen. Groups can also have titles. So if this is my mitigation plan for this negative branch reservation, or the undesirable effect, I can just press Tab, and then a title editor for the group appears, and I can say mitigation plan. So when I press return, that's part of the group now. And if I don't want to deal with that anymore, if I want to work with the rest of this, I can use this widget in the upper left-hand corner to collapse the group. Now the group is basically, you can see the edges that enter or exit it, but you can't see what's inside the group. Let's open that up a little bit here. And let's say I have more than one way of mitigating this. Let's say I have another way, like, I don't know, I'm not even going to try to make this logical at this point. I'm just going to create, say, another group inside this here. Because that's really what I want to show you, is nesting groups. So I've created another group. I'm going to give it a title. And let's say I decide, oh, well, this precondition really needs to be part of this group. So you, again, this is one of the gestures. You drag from the selection or the entity or group of elements that you want into the group, and Flying Logic really moves it into the group. Similarly, you can move anything in or out of group at any time you want. Whether it belongs inside of the group, that's up to you. You can even move multiple items at one time. Click, shift click, drag, and you've moved them. Drag them all the way to the top level. It doesn't matter where you drag as long as you've indicated the top level, because again, Flying Logic lays things out its way. And Flying Logic always tries to make sure that elements with no predecessors appear at the beginning of the flow, and elements with no successors are at the end of the flow. There is one thing, a couple of things you can do about that. So far, I've been using this left to right layout. As you can see, the evaporating cloud used right to left layout. And what direction of layout you choose is set in the layout, the orientation pop-up of the layout inspector. So if I want bottom to top, if I prefer that with my goal at the top, I can do it that way. Sometimes you want top to bottom. It's up to you to decide which way you want to lay things out. Now, real quickly, this is a good time to talk about another distinguishing feature of Flying Logic. If you've used things like mind mapping software or things like that, you know that you often have a central concept that's broken down into sub-concepts that broken down into their child concepts. And that is what computer people like me would formally call a tree. It has a root, and then each node in the tree has one or more children, and they can have one or more children, but each child can only have one parent. Flying Logic is based on a more general concept called a directed acyclic graph. And I know that's a mouthful. It's often abbreviated to DAG, but all that really means is that, let's go back to bottom to top here, is that it's a little bit more flexible than a pure tree, because in a DAG, a parent can have more than one child, like C has H and this junctor as its children, but a child can also have more than one parent, like this goal has 4 parents. Okay, it has the junctor, these junctors, and this action as its parents. So, and the simple way of putting that in plain English is that causes can have multiple effects, but effects can also have multiple causes. And you can't represent that with a simple tree. So you need something more flexible, like a directed acyclic graph. And that's the basic structure that Flying Logic is based on. The groups here are a tree. So you have the top level, and then you can have multiple groups. For example, I can say, put these things into a group, and I can create another group inside that. So the groups themselves are a tree. They go from top down. There's the top level, then there's groups inside those, but each group can only be contained directly in one group. So that's kind of a tree that doesn't look like that. And again, just by way of demonstrating, you can even move groups, from group to group. You just drag from the group to another group. There it is. You can even drag it deeper. You can do multiple steps at once. If I want to put this all the way at the top level, I can do that. So, how you group things is very flexible. It's also very easy. For example, let's say I put that group in there, to both, if I collapse this group and collapse that group, then I have, and let's collapse all the way back up to the top. I have this, group, which is not just the mitigation plan anymore, but that doesn't matter. And I can drill down. So if I want to, for example, if I'm demonstrating to somebody else, and I want to progressively reveal my diagram, I can, have them all collapse and then drill down one by one into them. Or if I want to drill down all at once, let's collapse that and collapse that. I can hold down the Option key and click on it, and then I can deep expand all the levels all at once. So you can deep collapse or deep expand, and there's command menus for that. So I can say go group, deep collapse selected groups. There's keyboard shortcuts for all these things. So it's up to you to decide, which things you want to, cultivate the muscle memory to learn how to do, but there's shortcuts for all of those things. So we've introduced the 4 kinds of elements in Flying Logic. There's all kinds of other little features, like groups can have colors. So you can say, make this a red group and help it be visually distinguishable from other groups. But one feature that I think that everybody needs to know about Flying Logic is called hoisting. And hoisting is basically kind of the opposite of collapsing. When you collapse something, you basically hide the group and you're dealing with everything else outside the group. When you hoist, you're dealing with everything inside the group exclusively. So if I right click on the group and say hoist group, now the whole canvas has changed. So now I'm just looking at the contents of that one group. And you can see these stubs appear where it goes outside the group. You can't do much with them, but you can basically work inside the group. So now if, for example, if there's another undesirable effect of the goal, and I wanted to have a mitigation plan for that, now I'm working just inside this group. And let's say I wanted to say group this. So I'm going to group that as a mitigation plan for that. And then I'm happy with that. Now I want to pop out. And as you can see, there's this path here. I'm in this group, which doesn't have a title. I'm inside, a group which has a nonsense title inside mitigation plan inside the top level. So I can just pop up one level by just clicking that. And then I'm now up one level. Or I can go all the way back to the top level like that. So you can see all the work I just did inside of that group. So this is one of, again, several ways Flying Logic gives you to manage larger documents. Collapsing, hoisting, as I mentioned before, there's the navigation inspector, which shows you a thumbnail. So if you just want to show very specific parts of your diagram, you can use the navigation inspector to get around quickly. You can use the scroll wheel, option with the scroll wheel to zoom in and out quickly. I use that a lot. So because you asked about quick capture, let me introduce that, because that's something that there's actually a new feature in Flying Logic 3.1 I want to touch on briefly as well, because quick capture is one of the earliest suggestions. It was actually Lisa Scheinkopf who wrote the book Thinking for a Change, the first book I read on the TOC, who said that she often works with groups and she often wants to capture, say, a whole bunch of undesirable effects. She's going to do what's called a current reality tree, where you do a root cause analysis on whatever's going wrong in your organization or system. So I'm going to create a new document here. I'm going to open up the effects-based planning and select undesirable effect. And so quick capture is in the text inspector. There's this little unobtrusive little button. This is kind of an italicized entity called quick capture. And so if I'm working with a group and I want them to just kind of start calling out the things that that they're experiencing, which are negative about the current situation, I go into quick capture and it brings up this little dialogue. And basically you can start basically, okay, what's one thing? So they say one thing and you type it and you press return. You type another thing and press return. You type another thing and press return. And so basically it's creating entities of the type I currently have selected over here, undesirable effects, easily in one step. Now, sometimes you want them to be like already connected in a chain of some kind. And so you can actually say, add edge to currently selected entity. And now when I continue this, then the new entities will be added as a predecessor of the thing. So it's up to you to decide which style you want. But once you have all those things, then you can say done, and then you can basically start actually connecting them up to each other as a kind of a causal relationship like that, and start building your current reality tree. So that's a way of just kind of capturing information pretty fast. Let's say I was working in a scenario where I already had some text in another document. Say, for example, I have my Flying Logic webinar notes here. And so the resources that I cover, and this is using a tool called Bear, which uses Markdown. So actually, even this shows bullets, they're actually asterisks. And so, but each of these lines, if I just copy and paste these to a text editor, you'd see star space and this. So I'm going to copy this out of this other tool entirely. And they'll go to Flying Logic and say, okay, I want these to be, say, I'm going to make these general, so they're not going to have a title bar on the top. And then I'm going to go to the edit menu and say, actually the entity menu, and say new entities from list on clipboard, or Command Option V. And basically what that does is that causes Flying Logic to create entities with those titles. Notice that it even smartly figures out that they all start with asterisks and removes those. So if you start with asterisks or bullets or some other sequence of the same characters, it automatically cleans those up. And so therefore, now I have my diagram that I can start working with those things. So, but I wanted to let you know that obviously, being able to copy and paste just from text and create entities this way, quick capture has been around forever. This feature I just showed you, create entities from list on clipboard, is new in 3.1. And what was a user suggestion? They said, well, I want to be able to do this. It's like, yeah, you ought to be able to do that. So we made it. So that's something that we definitely value user suggestions. So please put that in the forum so I don't lose track of it. All right. So the one last thing I want to touch on before we wrap up is domains. I've been talking a lot about classes and domains, but I want to point out that Flying Logic, the domains that are basically groups of empty classes. There's the general domain, which has generic and note in it, effects-based planning, which we've been sticking with, conflict resolution we touched on when we did the evaporating cloud. There's a couple others. These are built into Flying Logic, but you can create your own domains for your own purposes, because again, I'm not trying to limit you in Flying Logic to certain kinds of thinking, certain kinds of diagrams. The examples certainly if I go to file, let's see, file, open examples. Like for example, if I go to concept map, here's one way of doing a concept map in Flying Logic. This is actually using a custom domain with two new kinds of domains, one which is for the concept, one which is for the relationship between those concepts. And this is one way of doing it. You can also use edge annotations for the concepts that relate the relationships that relate the concepts to each other. It's up to you. But if you want your own custom domain, Flying Logic lets you create your own. So for example, I can start with say a goal, and maybe I'm writing a screenplay or something like that. And this is a goal for a character or a protagonist. And to do that, there has to be certain plot points. So if I wanted to create a domain, for example, so for screenwriting, notice that I clicked the new domain button, and then I created this new domain. I titled it. Now I could close this, but you don't want to close this. This is, again, something people get a little bit confused about with Flying Logic, but you leave this open as long as you're editing domains and classes. Because now I just go over here, press new class, and a new class appears inside that domain. And I say, okay, so this is a plot point. And I'm going to make this, say, deep blue. And I'm going to give this a symbol. I want this to have this speech bubble here. As the symbol. So whenever I use this is a preview of how that entity will appear. If I turn off show name, then it will be a solid color with the symbol, and the text will take up the whole space. It won't show that stripe bar at the top. So that's up to you to decide which it makes more sense to you to use. When you have Flying Logic's project management features on, you can also decide whether a particular class is a milestone and how its resources should be allocated. We're not going to go deeply into that right now. But let's say, and let's say I wanted to have annotate a central kind of plot conflict. So I'm going to have another class here, which is a conflict. And I'm going to give this, say, I'm going to use this speech bubble here. And of course, I'm going to make it red. And now that I have these, I can basically say that, okay, I have several plot points that need to lead up to this, kind of in sequence. At this point, there's going to be a conflict that has to be resolved to reach that plot point. And again, how these arrows are read, what these entities mean is completely up to you. Flying Logic doesn't impose that. The confidence spinners may mean nothing in this context, depending on what you're doing. So it's totally up to you to decide. But Flying Logic lets you mix and match. So if I want an action that leads to that plot point, I can just mix that in, and this is saved with the diagram. And so when you save this diagram out, your custom domain is saved with it. If you want to use that custom domain in a number of documents, you can actually say export domain screenwriting. It saves it as an xlogicd file, which is just a domain. You can open that up, and that opens up as a new document with just that domain in it. You can import it into an existing document. You can save this whole thing as a template, which will include your thing. So Flying Logic is very flexible how it lets you do domains. There's the domain menu where you can basically save domains as defaults. So if you use a certain kind of domain all the time and you just want it to appear no matter when you open a Flying Logic document, you can do that. So there's a lot of different ways people find to use Flying Logic. It keeps surprising me, and I've used it for things like network architecture, and as I mentioned, software dependency diagrams, and of course TOC stuff. So I set out to create something that was inspired by the theory of constraints, and wound up creating something that was much more flexible, much more general.